Welcome back, Algebra Dose. This is section 1.4, solving equations. Let's get rolling. Verbal expressions to algebraic expressions. So what we want to do is we want to write an algebraic equation to represent the following A and B sentences or expressions. So the sum of 2 and a number is 5. What we're going to do is we're going to add two things together, and we're going to set them, because of the is, we're going to set them equal to 5. That's going to give us, yes, 2 plus a number x equals 5, or you can actually put x plus 2 equals 5 and get the same thing. Letter B. The difference of 2 and 3 times a number is 11. Notice the difference gives us a minus, so we're going to take 2 and 3 times a number, let's call it 3x. Problem is it 3x minus 2 or is it 2 minus 3x? It's the difference of the first one minus the second one. So and set it equal to 11. Good job. So within solving equations, we actually have properties. So these are called properties of equality. Okay, first one you've seen before, especially in geometry. For any real number a, Reflexive says it could equal itself, so we'll say A equals A. Example, if we take just the number 4, we can say that 4 equals 4. Next one, symmetric. For all real numbers A and B, if A is equal to B, then we can flip it around and say that B equals A. Example, so if we said that x, our variable, equals 4, we can say, and flip that around, that 4 is equal to all x. Okay. Transitive, for all real numbers A, B, and C, we can say, well, if we know that A equals B, and we know that B equals C, then by transitive property of equality, we can say that A is equal to C. Example would be, if I said x is equal to y, and you knew that y was equal to 4, then we can simply substitute and say then x equals 4. And the last one, substitution. We're going to say if a equals b, then a may be replaced by b, and b may be replaced by a. So if we start off with 2a plus 4b equals 3b plus 6, and you know that a equals 2, what I can do is, let's get rid of all these b's. So we can put in 2a plus, let's substitute in a for b, call it 4a, and instead of the 3b, let's make it 3a plus 6. Now what we can do is we can use substitution and input in all the a's. So we have 2 times 2 plus 4 times 2 equals 3 times 2 plus 6. Okay. By using simplification, 2 times 2 is 4, plus 8 equals 6 plus 6. Therefore, we get 12 is equal to 12, which is a true statement. Name the property illustrated by each statement. Number 1, if we have a minus 2.03 and it's equal to a minus 2.03, nothing's changed, we haven't switched anything around, that's going to be the, yes, you guessed it, reflexive property of equality. If 3 equals x, and we know x equals y, and then we use and say that 3 equals y, that is the transitive property. Okay. So more properties of equality. We also have addition property of equality, we have subtraction property of equality, multiplication property of equality, and division property of equality. Okay, examples. Addition is just simply saying if a is equal to b, then we know if we add the same number, you should get the same thing. So if x equals 12, then we know x plus 3 is really equal to substituting in 12 and getting 12 plus 3, or 15. Okay, if we subtract, so again, if x equals 12, then x minus 3 is really 12 minus 3, which is 9. Multiplication property, staying on the 12 theme. If x equals 12, Then x times 3 would just simply substitute in 12 and get 12 times 3 or 36. And division, as long as we're not dividing by 0. Okay, so if x equals 12, then x divided by 3 is equal to 12 divided by 3, or 4. Using the properties we have just learned, okay, we're going to solve for unknown variables below. Okay, remember the goal. Goal is to get the variable by itself. If we're subtracting, we're going to add the opposite across the equal sign. So 5.48. If we add that, we end up getting s is equal to 5.5. Okay. Here, we have a multiplication property, but we need to get t by itself. Which means, how do we get a 1t? That means we have to get rid of this. Well, the best thing to do is take 18, take the 2/3. We're going to multiply, or get 1. We're going to multiply by the reciprocal. So we're going to multiply 18 by 3 halves, which leaves us with t is equal to, that goes in 9, so we get 27. And 5, we're going to have to get rid of the grouping symbols. In order to do that, yes, you guessed it. It's what property? Distributive property. So 53 equals 3y minus 6 minus 6y plus 2. Let's combine like terms on each side. There's only a 53 on this side. 3y minus 6y is negative 3y minus 4. Okay. Now the goal is to get this y by itself, so we have to add 4 back the other way. We're going to get 57 equals negative 3y. Okay. Because it's multiplication, the opposite of multiplication would be considered division. So we divide by negative 3, and you get negative 19 equal to y. Let's ask ourselves the question now, what if we get equations with no solutions or identities, meaning themselves? Or in other words, what happens? So is the equation 11 plus 3x minus 7 equal to 6x plus 5 minus 3x? Always, sometimes, or never true. So let's combine like terms on one side. Let's get 3x plus 4, and that's equal to, if we combine these two here, we'll get 3x plus 5. There's two ways to look at this. Let's just move one thing to one side, or we can subtract the 3x first. You get 4 equal to 5. Okay. Is 4 ever equal to 5? The answer is no. So this will never be true. Okay. So what about 6x plus 5 minus 2x equals 4 plus 4x plus 1? Okay. Let's, again, combine like terms first. If we were going to solve for a variable, if we get 4x plus 5 equal to 4x plus 5. Is 4x plus 5 equal to 4x plus 5? Yes. If you're confused, it's okay. Let's move the 4x over. Move the 4x over, and you get 5 equal to 5. Is that true? Yes. So that is 5 always equal to 5? Always. Last one. Solving a literal equation. The equation C equals 5/9 times F minus 32 relates to temperature in degrees of Fahrenheit and degrees Celsius C. We want, what is F in terms of C? In other words, we're going to flip this around and we're going to actually solve for F. So if we rewrite and say, okay, if I need to get F by itself, okay, the first thing I want to do is I need to get rid of this 5/9 on the outside. Well, in fraction form, the best thing to do, and in order to move it across, because it's multiplication, we're going to multiply by its reciprocal. So if we multiply by 9/5, F, so if we multiply by 9/5, we end up getting 9/5 C equals This turns into 1, and we have f minus 32. Okay, now we can get this by itself. Adding 32, we know that f is equal to, we cannot combine these, they are different. One has a variable, one is just a constant. So we'll leave it as 9/5 c plus 32, which is the conversion equation for Fahrenheit. Okay, or we can flip it around and just f degrees is equal to 9/5 c plus 32. That's it for chapter 1.4. Hey, always remember, do your best, forget the rest. Otherwise, you'll end up like Eli. Bye for now.